Hello guys, we need to determine the z transform of this sequence. If you have a function, for example, f of k will be equal to 0 for k is equal to 0 and k is even, and equal to 1 for k is odd. If you need to draw this function for simplicity, you draw this k, axis k, and this x will be f of k. So it will be 0 at k equal to 0, and 0 for k is even for 6, and it will be equal to 1 for k is odd. And so on. Okay, the equation for z transform f of z will be equal to summation from k equal to 0 to infinity f of k times z to the power of minus k. Okay, so f of z will equal to, you expand this summation, it will equal to f of k will equal, for k equal to 0 here, f of k will equal 0 times z to the power of minus 0. Okay, 0 to the power of minus 0 plus k equal to 1, f of k will equal to 1, this is the value of k equal to 1, so it will be equal to 1, z to the power of minus 1, and 0 to the power of minus 2, and 1 to the power of minus 3, and so on. Okay, so this go, we left with f of z will equal to z to the power of minus 1 plus z to the power of minus 3 plus z to the power of minus 5 plus z to the power of minus 7. So if you could note here, it's an infinite series, and and k will be odd here. Okay, you can lift this as an infinite series. This solution will be acceptable. But if for some reason you need a closed form for f of z, how can you make this? Okay, if you note this, if we make this equation 1, if you multiply equation 1 by z to the power of minus 2, f of z times z, let me clear it, f of z times z to the power of minus 2 will equal to, the right hand side, if you multiply this times z to the power of minus 2, we will get z to the power of minus 3 plus z to the power of minus 5 plus z to the power of minus 7 plus and so on. This is equation 2. Okay, alright, now if you subtract equation 1 minus equation 2, what you'll get here? Okay, let me make some, sorry, okay, just I'm so sorry for this delay. If you subtract 1 from 2, what you'll get now? You get fz minus this term, got fz, f of z minus z to the power of minus 2 f of z will equal to, if fz minus fz to the power of minus 2. If you subtract this equation 1 from equation 2, you will note here, if this will be minus sign, so it will go this with this, this with this, this with this, all this series will, so we left with z to the power of minus 1 here, z to the power of minus 1. Okay, if you take f of z, it will lift 1 minus z to the power of minus 2 will equal to the z minus 1. Alright, so f of z will be equal to z to the power of minus 1 over 1 minus z to the power of minus 2. Okay, you can lift this as a closed form here. If you multiply the above this equation the numerator and denominator by to the z of 2, what you'll get, f of z, you'll get here, if you multiply by z to the power of 2, the numerator and denominator, you'll get z squared minus 1 minus 1, and here will be z. So this is a closed form solution for our problem. If you need to review it, we got this sequence f of k, and we need the z transform for that, so we end up with closed form. This is a closed form solution, and this one, f of z, z to the power, this one is infinite series. This solution will be an infinite series, and it's also a true solution. So thank you for watching. For this, I am very sorry for it's not a good presentation, but I think I hope this video will help you, and I'll improve my performance in the next videos. Thank you for watching, and see you next time.